Hello students, I welcome you to the first module of chapter 3 Understanding Quadrilaterals. Let's start with the recap. In our previous class we have learned about polygons. What is a polygon? It is a simple closed figure made up of 3 or more line segments. As you can see on the board, I have drawn a few polygons for you. It is a polygon with 3 sides. It's a polygon with 4 sides, 5 sides, 6 sides and so on. Now focusing on this area, we'll come to this on later part. On this part you can see I have marked these two shapes. So what does this represent? Although these two are pentagons, these two are hexagons, but there is a difference. The difference is that the line segments are not equal, but in this figure, all the line segments are equal. So we call this a regular polygon. Regular polygon. It means all sides and all angles are equal in this. Now coming to this portion, it is not a polygon. Reason, it is not a closed curve. This is not a polygon, although it is a closed curve. Reason, it is made up of line segment as well as a curve. Now you can see these two figures marked as A and B. Are they polygons? Yes, they are polygons, but they come under a different set of polygons called concave polygon. So, polygons are of two types. Polygons are of two types. They are one, convex and 2, concave. So all these polygons come under convex polygon. Convex polygon. But these two come under, that is A and B. A and B comes under concave polygon. Now we will. All these polygons are convex polygons, whereas these two are concave polygons. Now I'll tell you why they are called concave polygons. First, they intersect. They are not simple closed curve. Second, you can see one of these angles. This angle. Can you see this angle? This angle is a reflex angle. Reflex angle means angles greater than 180. Whereas in convex polygons, you observe any angle, all these angles are less than 180 degrees. Similarly, this one, these angles are all less than 180 degrees. So, in a polygon, if one of the angles or more than any one of the angle is more than 180 degrees, this is come under concave polygon. Coming to the types of polygons, convex and concave, we can see that each interior angle of the polygon is less than 180. Less than 180 degrees. Whether it's a four-sided polygon or it's a five-sided polygon, we can see each angle is less than 180 degrees. Whereas in concave polygon, you can see one or more. So this angle, this is a reflex angle, and that is greater than 180 degrees. So this is one of the major point of difference between convex and concave. Now coming to diagonals, that is the second differences of diagonals. We know when we join opposite vertices of a polygon, it forms a diagonal. And if I joined adjacent vertices, it forms the sides of the polygon. So in terms of diagonals also we can see in convex the diagonals completely lie within the figure. Whereas in concave polygon you can see the diagonal lies outside the figure, and in this figure it lies partially outside the figure. Now students, let us learn how to find the sum of interior angles of any polygon. I have drawn three polygons here: quadrilateral, hexagon and heptagon. So I'll show you how to find sum of interior angles of these three geometrical shapes. The first quadrilateral. I have joined one diagonal. Here I have taken one vertex and joined all the possible diagonals. Similarly in heptagon also I have taken one vertex and joined all the diagonals. Now this quadrilateral, one diagonal will divide the quadrilateral into two triangles, and we know in triangle the sum of the interior angles makes 180 degrees. So if I add up these three angles of triangle 1, I will get 180 degrees. So let's name this angle as A, this angle as B and this angle as C. So we know from our previous knowledge, we know that angle A plus angle B plus angle C is 180 degrees. Similarly, if I can name this and add up, so let me name this as 1, 2 and 3. So we have angle 1 plus angle 2 plus angle 3 is 180 degrees. So when I add up all these will form interior angles of the quadrilateral, and the sum will come to A plus B plus C plus angle 1 plus angle 2 plus angle 3 will be equal to 360 degrees. Or I can say it is 2 into 180 degrees. Similarly, I'll see in this hexagon, which is a six-sided figure, you see that the diagonals are dividing the triangle into four triangles, that is 2 less than the number of sides. In quadrilateral also it has been divided into two triangles, that is 2 less than the number of sides. So here also I can find the interior angle sum of hexagon as 4 into 180 degrees. Why 4 into 180 degrees? Because it has been divided into 4 triangles and sum of each triangle is 180 degrees. So we have 4, so we will get 720 degrees. Now we take a heptagon, which is a 7-sided polygon, and here we can see we have divided the hexagon into 5 triangles. Similarly, we can find the sum of interior angles of a heptagon as 5 into 180 degrees. 5 into 180 degrees is 500, 5 8s are 40, 5 minus 5 and 4, 900 degrees. So this is the sum of interior angles of a heptagon, 720 degrees, in sum of interior angles of hexagon, and 360 degrees sum of interior angles of a quadrilateral. So if you have observed this figure carefully, we have seen that each polygon has been divided into 2 less triangles. So if I have a polygon, if a polygon of n sides, then what will be its interior angle? Can we derive a formula? Yes, we can divide it by looking at this. So if the polygon has n sides, we can divide that polygon into 2 less triangles. That is, I can divide it into n minus 2 triangles, and the sum will be n minus 2 into 180 degrees. So we come to a conclusion that sum of interior angles of a polygon of n sides will be n minus 2 into 180 degrees. So even if you forget the formula, you can always remember these. It is divided into two less triangles. You can find it by the formula n minus 2 into 180 degrees. Now let's find the measure of each interior angle of a regular polygon. Suppose if a polygon has n sides, sum we know, we find it as n minus 2 into 180 degrees, and each angle will measure n minus 2 into 180 degrees by n. That what is n here? N is the number of angles. So this will give you the measure of each interior angle of a regular polygon. That you should understand. We cannot use this formula to find for a non-regular polygon. It is exclusively for regular polygon, because only in regular polygon each angle is equal. Let's use this formula to find the sum of interior angles of a regular octagon as well as to find the measure of interior angle. So octagon, it is a 8-sided polygon. Sum will be here n is 8. So 8 minus 2 into 180 degrees, that is 6 into 180 degrees. So the sum comes out to be 1080 degrees. Now we'll find measure of each interior angle of a regular octagon. So this we have taken it as to be regular octagon. So it will be n minus 2 into 180 upon n, where n is 8-sided polygon, so n will substitute as 8. So we'll have 8 minus 2 into 180 by 8. So that will give me 6 into 180 degrees upon 8. And we have already found out 6 into 180 is 1080. So I can substitute 1080 upon 8. So the answer will be, you can find out the answer. And it comes out to be 135 degrees. So now we have seen how to find the sum of interior angles as well as to find the measure of each interior angle of a regular polygon. Next we will see how to find the sum of measures of exterior angles of a polygon as well as measure of each exterior angle of a regular polygon. Let's see the exterior angle property of polygons. I have taken a triangle. You can see that A, B and C are its interior angles, and I have marked 1, 2, 3 as its exterior angles. So again, we need to find sum of exterior angles. For that, we'll use the previous knowledge, that is sum of interior angles. So in this figure 1, we have angle A plus B plus C is 180 degrees. Where did we get this from? Angle sum property of triangles. Property of triangles. So now 1 plus angle A, that is, this forms a straight line and we call it linear pair. Angle 1 plus angle A is 180 degrees. It forms a straight angle, or we say it's a linear pair. Similarly, I can write angle 2 plus angle B is also 180 degrees. Same reason. And angle 3 plus angle C is again 180 degrees, reason being the same. So from these equations I can find exterior angle. So exterior angle 1 will be equal to 180 minus angle A. Angle 2 will be 180 degrees minus angle B, and angle 3 will be 180 minus angle C. So we have to find the sum of exterior angles, that is angle 1 plus 2 plus 3, which we'll find from here, that is angle 1 plus angle 2 plus angle 3 is equal to, we have 183 times. So I can write this as 180 into 3 minus angle A plus angle B plus angle C. And we know that A plus B plus C is 180. So I'll substitute here and I'll find it as 300, 3 8s are 24 and 3 1 is 3 and 2 is 5. 540 minus 180 degrees. So it comes out to be 360 degrees. 360 degrees. Similarly, you can find the sum of exterior angles of a quadrilateral using the same method. I'll show it here in short. We know A plus B plus C plus D is equal to 360 degrees. That is, we have seen before. Now we have 1 plus 2 plus 3 plus 4 is equal to, same way we'll use this one. Angle 1 is 180 minus A, angle 2 is 180 minus B, angle 3 is 180 minus C, and angle 4 will be 180 minus D. So I can use it as, and I'll get 4 equations, and so I'll write 180 into 4 minus A plus B plus C plus D. So that will be angle 1 plus 2 plus 3 plus 4. These are exterior angles of a quadrilateral, and their sum will be 180 into 4 minus A plus B plus C plus D. And we know the sum is 360 degrees. So I can find it out as 180 into 4 minus 360 degrees. So when I solve this, I'll again get minus 360 degrees, which is again 360 degrees. So we see that exterior angle of a quadrilateral, sum of exterior angle of a quadrilateral as well as triangle is 360 degrees. So what do we conclude here? Irrespective of number of sides, the sum of exterior angles of a polygon remains same, that is 360. Whether it is a quadrilateral, whether it is a polygon of 5 sides or 10 sides, we see that the sum of exterior angles will remain same, that is, it will be 360. So this concept you can use for finding out many problems like finding number of sides of a polygon, or finding the measure of each interior angle of a regular polygon, or sum of interior angles of any polygon. Let's take another example where we have interior angle of a regular polygon is 156 degrees. We need to find number of sides the polygon has. So can do it in two methods. First, we can use interior angle property as well as exterior angle property. I'll show you in both ways. Let me first take interior angle property. We know sum of interior angles of a polygon of n sides n minus 2 into 180 degrees. But being a regular polygon, measure of one angle is given, so I can write one angle is equal to n minus 2 into 180 upon n. And we have the measure, so we write 156 degree is equal to n minus 2 into 180 upon n. So, when we solve this, we have n into 156 degrees is equal to n minus 2 into 180 degrees. So 156n is equal to 180n minus 360 degrees. So we have 360 degrees is equal to 180n minus 156n, or 360 degrees is equal to, when we subtract, we have 10 minus 6, 4, 7 minus 5, 2, 24n. So we have n is equal to 360 degrees by 24. So when you divide by 12, you will get 30 by 2, which is equal to 15. So we have, this polygon will have 15 sides. This we had used with interior angle property. Let's solve the same sum using exterior angle. So here, if I have a polygon, I don't know how many sides it has, so I'm taking it as an exterior angle, and here the exterior angle is given as 156 degrees. So I can find one interior angle of the polygon. So I'll find interior angle. Interior angle was given as 156. Sorry, this is not correct. Using exterior angle property. We know sum of exterior angles of any polygon is 360 degrees. But we have been given interior angle. We can find exterior angle as, exterior angle is equal to 180 minus 156 degrees. So that will be come out as 424 degrees. Therefore, number of sides is equal to sum of exterior angle upon measure of one exterior angle, that is 360 by 24, which is equal to 50. So students, you can find the number of sides of a polygon with any of these methods. Either use interior angle property or exterior angle property. Hope students, you understood the concept. Today we have learned, let us recapitulate what all we have learned today. We have learned to find number of sides, number of angles, sum of exterior angles, sum of interior angles, and number of radii. Hope you have understood today's lesson. We have done module 1 of understanding quadrilaterals, which covers exercise 3.1 and 3.2 of NCERT. I would like students to try out those exercises, and I'll be sending you the link of understanding quadrilaterals and the exercises which you have to do in your WhatsApp group. Thank you.